Okay, so kind of finished up with this, and so this is a first thing that I would say. I would say this is a guaranteed test question. So this is a test question. It's going to come up. I'm telling you right now that this is always on the test. So right here, this is a test question. So IB always asks this, that there are two types of reactions that are always exothermic. So these are exothermic all of the time. And so what that means is that if you can identify the type of reaction, that's going to help you solve the problem. So you have to know the two specific types. Okay. So one of these types, think about our reaction types. There's the reaction types we've talked about. One of these is very common. And so this should be logical to you. So the first one is combustion. Remember, IB loves combustion, one of their favorite types of reactions. So combustion, things are blowing up, right? Fireworks and things that are giving off energy. That's combustion, and so things that so for us, combustion is normally like a fuel, right? So a fuel with oxygen gives things off, and so we just have to recognize combustion. And so we want to recognize that you have the fuel. So that's some combination of C's and H's plus oxygen yields carbon dioxide and water. So every single time we see that one, we need to be thinking, hey, this is exothermic. And so that's going to mean something moving forward, because you're going to have situations where the if you don't know that's combustion, then you could get the problem wrong because you may not have the right sign. We spend a lot of time with signs in this particular unit. So combustion, number one, got to remember that one. Okay, so let's make sure we know that. Okay, so that's combustion. And so we're going to move on and take a look at the next one, which is one that you guys really have not had much experience with, and that's an acid base reaction. Had very little experience with this. Okay, so an acid base reaction is called neutralization because the acids and the bases come together and they neutralize each other. They make water. So you got to be able to spot this. So what are you looking for? You're looking for acids. You're looking for bases. So what are you looking for? Well, acids, you're going to be looking for something that has a hydrogen in front. There's your acid. And for a base, you'd look for something that has OH, usually at the back of it. Just kind of clean that up a bit. And for the bases, you're looking for the OH negative, which is a base. So just look for acids and bases. And it's usually an acid plus a base. So you're going to be, it can be a lot of things. I will give you a very quick example here. So you could have like hydrochloric acid, HCl, plus some potassium hydroxide. And so see, this is my acid here. Starts with H, and then there's my base. It's got the OH. And so you've got to be able to identify these. There's the acid, there's the base. And then what they turn into is it would go ahead and turn into a, let me go ahead and zoom out here. It would turn into hydrochloric acid plus potassium hydroxide. It's double replacement. So the K, don't want to do that. So the K there you go. The K is going to be with the chlorine now, and then makes water on the back end like that. And so crisscross these, +1, -1. There we go. There's your formula. So the key thing is to identify these, the acid and the base, which then tells you, hey, I have what we call neutralization. So you've got to memorize these. Test question, if you see these, automatically exothermic means it gives off heat. Okay, so let's jump into endothermic. Endothermic means the heat is absorbed. And so let's go put this right here. Heat is absorbed and so if heat's going to be absorbed, then that's going to feel cold. So this is going to feel cold, or the temperature is going to be going down like that. And so maybe we should just put temperature decreases. These are not very common. We don't have as many reactions where the temperature actually goes down, because in terms of chemistry, it's actually more favorable for reactions to give off heat, because that means that they're more stable. And so this is kind of a rare reaction type. But what happens is that you have the energy being sucked into the reaction, and it makes the area around it feel cold. And so when you're if you have like a chemical ice pack, right, and you break it and it starts to feel cold, then that's what's going on here. Like I said, this is not a very common reaction. All right, we got heat. So number 1, Q, says heat is the measure of total energy in a given amount of substance, and therefore depends on amount present. Okay, Q is a value given off, and so Q is heat. So we'll do a lot with heat, and so Q is one of those items we can look at. And so what we start to look at is that heat and temperature are related, but they are not going to be the same exact thing. So what is temperature? Temperature measures average kinetic energy. And average kinetic energy is how fast particles move. So average kinetic energy, or in parentheses, how fast particles move, or the speed of particles. So if you heat something up, the particles go faster. If you cool it down, the particles go slower. So if we're looking at particles and how temperature is related to heat. So now it says, in general, temperature depends on, and then we got a blank here. So in general, temperature is going to depend on heat. So how much heat did we add? So number 1, how much heat did we add? So that's like the Bunsen burner, the hot plate, whatever. The mass of whatever we are heating up. And last is going to be the type of substance. And so some substances are easier to heat up than others. You already know this, right? Like if you try to heat up a piece of metal, it heats up really, really easy. So like the pan, like if you're heating up water on your stove, the pan heats up really quick. But the water takes a while, right? Like you're going to go home and you're like, man, I am really hungry. School was tough today. And so you are heating up some water on your stove and you're going to make some mac and cheese, right? So you're trying to get this stuff to boil. Well, that pan gets hot really, really, really fast. It's made of metal, but that water takes a while to heat up. We call this concept heat capacity. So specific heat or heat capacity is this idea that different items are going to heat up at different rates. Water has a large heat capacity and it's very slow to heat up. So that's why if you're next to the ocean, the temperature is pretty similar all year round because that huge body of water keeps the temperature of the cities next to the coast. It keeps them in a very small range of temperatures. Where if you aren't next to a huge body of water like the ocean, the temperatures can fluctuate more. So that's just the idea. Some things are harder to heat up than others. Okay, so I'll zoom in here. So direction of heat flow. Now we're going to start talking about things going in, things going out, and we're start to add in this new thing, which is the plus sign or the minus sign. Okay, that's going to be really, really, really important through this whole unit. The plus sign or the minus sign. The plus sign. Think about a plus sign. So you're adding energy, and so the plus sign is going to be endothermic. And that means that the energy is going in. And so it's pulling in the energy and that the heat is going to be absorbed. And so a positive Q, a plus Q means that the heat is absorbed. Now the minus Q going the other way, that's exothermic. And the heat's going out. So it's pushing out. It's going back into the surroundings. That's why you can feel it with your hand, right? Like if you're touching something. So heat's going to be given off. All right. So this one is heat in, and this is heat out. All right, a couple more things, and we'll probably stop. We're going to run out of some time here. So let's look at enthalpy real quick. Extensive property and state function. If something is extensive, then what that means is that amount matters. How much you have matters. And so if you have a big container of water or a small container of water, the amount matters. And so it's going to depend on amount. So for example, density is not extensive. It doesn't matter how much you have because it's always the same no matter how much you have or how much you don't have. But we're talking about some of these concepts of heat and heat in and heat out, or delta H, the amount is going to matter. So, all right, I'm going to stop here because we're going to run out of time.